Question 1 says a resistor R, which is 40 ohms, is connected to a 230 volts 50 Hz supply. So we are asked to find in A, the peak value, B, the current flowing and the power dissipated in the resistor, and C says that if an inductor 50 millihenry is added in series to the circuit, what to be the total Z, that is the total impedance in rectangular and polar coordinates. And D, we are to find the current in the RL circuit. And the last question says we should find the power dissipated in the AC circuit. Right, so let's start with A. A says we should find the peak value. So we know that peak value is equal to, in the question we have our VRMS value to be 230 volts. So then the peak value, very simple, will be 230 times root 2. B says that we should find the current flowing and the power dissipated in the resistor. So now we know that V is equal to IR if we want current, but we have V to be 230 and our resistance to be 40. So then the current will be 5.75 amperes. So if we want the power will be current squared times the resistor. So now we know our current, that is 5.75 all squared times the resistance, which is 40. So we'll have a power of, or if you want it in kilowatt. So C says that if an inductor is added in series to the circuit, so the original circuit we have is a resistor. The question says if we add an inductor in series with the resistor, what will be the total impedance, our supply voltage. So if we want the impedance, which is Z, having a resistor and an inductor in series should be, but in the question they gave us the value of L, but we know that XL is equal to 2 pi FL. So I can find XL, that is 2 pi times F, which is 50 Hz, times 50 millihenries, that is 10 raised to the power minus 3. So I'll have my XL value to be ohms. So now the impedance will be very easy to find. I'll have R to be 40 squared plus the XL value, which is 15.707 all squared, and impedance value to be, so if you want to write this in the polar or rectangular form as the question said, impedance should be equal to R plus JXL, the resistance which is 40 plus JXL, we had XL to be 15.707 in the polar form. So you see that you have impedance value to be 42.973. So D says that find the current in the RL circuit. So now this is your RL circuit. So if you want to find current, I should be the voltage across the RL circuit, right? And the impedance across the RL circuit. So the voltage across the RL circuit is given here, that is 230 volts, right? So in polar, and we know the impedance right across the RL circuit, we had it here, that is it, which is, so E says we should find the power dissipated in the circuit, right? So we know that P is equal to, we have I already, that is what we found over here, that is 5.35 squared times the resistance in the circuit, that is 40. So then the power would be, an RL circuit is connected to a 230 volts 75 Hz, the rating of 750 VA. If the resistor is 40 ohms, what is the value of the inductive reactance and the inductance? So what we have to find is inductive reactance, that is XL, and inductance, that is L.
But before we continue, this video was sponsored by Sultan Drinks. Let's check this out.
revitalizing drinks made from millennial-old secret of black seed. Available in 4 flavors. Sultan Drinks. You know what you drink.
You've been given a power that is in VA. So in VA, we will say that it is an apparent power, right? So S is equal to VI, because when you have your power in volt ampere, that means your power is an apparent power, that is S, which is equal to VI. So from here I can find a current, because I have S and I have V, right? So my S, which is 750, out of the voltage, that is 230 from here, there's a supply, right? So I should have a current of 3.261 amperes, right? But the main focus is to find XL and the value of L, right? So, but we know that in an RL circuit, Z squared is equal to R squared plus XL squared. So if you want XL, will be equal to Z squared minus R squared. We already have R, the value of R, because R was given in the question, that was 40 ohm. But we are not given Z. But we know that Z is equal to current times the impedance. So Z will be equal to voltage over the current that we found. But we know V already, 230 out of the current that we found, that is 3.261. And this should give us 70.531 ohm. So XL, as I said, by substitution from here, will be Z squared, that is 70.531 all squared minus R. We have R to be 40. So 40 squared. So the value of XL, and in that case the inductive reactance, will be. So then if you have XL, you can find L, because this is equal to omega L, and omega is equal to 2 pi F L. L will be equal to XL out of 2 pi F, right? So you know XL already, we found it here. So it will be out of 2 pi times frequency, which is 75. So then we should be able to find the value of L, which is, thank you.